Um, in this demo, I want to give a kind of live tour of what it might mean to create a review that's decoupled from any publishing system, a review that can travel with any particular edition and can be verified by third-party client applications that are using it, and can pass that information on to their users wherever they might be on the web. So this is kind of a portal for creating a review, and creating a review of a text might look something like the following. A user can log in with their credentials. In this case, I'm going to log in with my GitHub credentials. And now the system knows who I am, and I can leave a review. Here are some existing reviews that have been made, and we'll go ahead and make another review copying this one. In the process of creating a review, I need to give it the data that I'm going to review. I can choose the society that I want to review, or I can provide a review as an individual person. If it's a given society, we might assume that a society might have different levels of review that they'd like to pass on. So in this case, they want to give it a level 1 review, and they might provide a description of the review. And it's as simple as creating a submit, like so. In creating a review, they've done actually several things. The unique fingerprint of the document they've reviewed has been logged using cryptographic hashes. And that precise document has been pinned to a peer review network called IPFS that is retrievable not by its location on any particular server, but by its unique cryptographic hash. Right? So you can see that I'm addressing this content not by where it is on a particular server, but by its unique cryptographic hash. So if a single bit is changed in this document, you won't get the same. It will have a different cryptographic hash, and this document won't be addressable. Secondly, we've created a open badge certificate following the open badges standard. And in this certificate, you can see a couple of things. You can see the public key that would belong to a particular society for which it alone has the private key. So this would be the public key for the Medieval Academy of America. And this unique certificate is also hashed, and a single change in this certificate would invalidate it. And within that certificate is the unique hash of the document that's being reviewed. So in this way, we can verify the precise document that this certificate is reviewing, and the badge that's being assigned to it. So a particular badge and the criteria that comes along with that badge. So a lot of this can be improved, but you see the basic idea. And this is just a registry that connects certificates with documents. Right now, the authenticity of a certificate is being verified because it's coming from the DLL review registry. But in the future, we'd like to move that verification claim off of any centralized server and onto a blockchain such as Bitcoin, the Bitcoin blockchain or the Ethereum blockchain. But all of this becomes a third-party service for other clients to use. You see that we documented the API, and basically any third party can send the cryptographic hash of the document they're using and discover if there are any certificates or reviews of this document. So let's look at how that looks in two different applications. So in this application, completely different website, I am offering users a representation of Lexia 1 of Peter Plau's commentary on the sentences of Peter Lombard. In selecting it, this website has chosen to render a particular document, and in the process of rendering it, it sent that document using the registry API over here to see if there were any reviews. It discovered one review, and it reports to the user, there is one unique review by the Medieval Academy of America for this unique document, this cryptographic hash. And clicking on this, I can see the review. I can see that it has precisely this cryptographic hash, and then it has this review, and the certificate hash would go here. And if I move to another document, you can see that while there's a data source, there's no review because it just checked the registry and there's no review for this document. Let's move over to a completely different application. This is a quotation explorer. It aims to present the same data in a wildly different way. In this case, it's interested only in presenting the quotations from the scholastic corpus. So let's say I'm interested in quotations from Peter Lombard's sentences, which are here. And let's say I'm interested in apologies, we want only the quotes in Peter Lombard's sentences. And we only want to see quotations from book 1, and we only want to see quotations from distinction 1, and that's good enough. And let's say we became interested in this particular quotation here. Right? Here we're giving you a rendering of the paragraph from which it's come, but you can see there's no review of this particular edition. But if I click here, this is a diplomatic transcription of this particular manuscript, and there is a review from the Medieval Academy of America, or a demo review, for this particular diplomatic edition. And this third-party site has simply sent the data it's intending to render to a review registry to discover if there's a certificate, and it can offer users access to that certificate. I can now check, see what the review was, see what level it was got, what rubric was used, right, what society used it, and I can always use the document hash to get the precise document that was being used if I don't trust the third-party service that is offering it to me. Right, and in this way, we can make data available in any environment for any given purpose and allow the imprimatur, right, to travel with that data in whatever way it's being represented. So that's it for now. We'll offer more demos as more progress is made, but this illustrates the basic idea of how a imprimatur can travel with the data independent of whoever's publishing or presenting that data to the end user. Thanks so much for watching.